So, hello everyone. My name is Francisco Falcone, and I am going to share with you my presentation, which I will be putting in my screen now, and which is entitled Distributed Opportunistic Wireless Mapplicationing System Towards Smart City Service Provision. This is joint work between colleagues from the Department of Statistics, Computer Science, and Mathematics and the Department of Electronic and Communications Engineering at the Pública University of Navarra in Pamplona, Spain. So we will go through the talk. First, we're going to give a brief introduction to the topic related with smart city application. Later on, we will provide a system description of the architecture of the distributed wireless sensor detection nodes that have been implemented. And finally, we're going to draw some conclusions and future work lines in relation with this work. So basically, the advent of smart cities is given by the fact that we want to increase the efficiency and the optimization of resources when we consider the fact that large arrays of populations are going to be living within urban dense areas. So it is a well-known fact that by 2050, over 70% of population will be living in cities or megalopolis. So therefore, it is compulsory to optimize the way in which we handle the multiple systems that are going to be providing the services within the city. So among these, we can have, for example, energy systems relating with smart grids and microgrid systems, hydric resource and the efficiency in the use of water, intelligent transportation systems, the way in which we can handle waste management, or the role that communication systems can provide in order to give interactivity and connectivity options within the city. Now, within this, it is interesting to note the fact that we're also going to have other type of elements that are going to be related not only with the technical aspects of the way in which the smart city works, but also in the way in which citizens are going to be interacting within the city. And this opens a very interesting aspect related with open government and open data. So what is going to be the goal of this specific work? Well, what we're going to be providing is the proposal of a distributed wireless signal applicationing system, which is going to be based on employing opportunistic measurement sensors. And basically what we're going to do is that we're going to take advantage of the widespread use of smartphones. Basically, what we're going to be capable of doing is we're going to be collecting geolocated Wi-Fi signal data, basically RSSI and SSID binds of data. And we're going to collect them, and they're going to be processed by this monitoring system, which is going to be, at the same time, enabled to interoperate with a smart city platform within the urban area of Pamplona, within the framework of a European project called Stardust. Now, this is going to be a distributed system, which is going to be a cloud-based, scalable architecture. And by extracting all this data, what we're going to be providing is a multiple data set, which is going to be capable of being employed in order to provide comprehensive information, which is going to be visualized by citizens in general. So let's move on now to see how this system is implemented. And as we were saying before, basically what we're going to have is a distributed set of nodes that are going to be taking measurements, and these measurements are going to be transmitted via whatever type of communication network we wish to establish. And once this is done, we're going to be providing a comprehensive data feed. There, we're going to be converting data into an amenable format in order for it to be introduced within a data storage system based on SQL. And from there, we're going to be using data visualization tools in order to provide comprehensive dashboards and information related with different aspects. Now, in order to implement the system, as we were saying before, what we're going to be doing is that we're going to be extracting data feeds, and these data feeds is going to be given by the data ingestion that is going to be given by different smartphones that are going to be distributed within the city of Pamplona. And what we're going to be doing is that these different smartphones are going to be collecting the data, and this data is going to be ingested, and within this data ingestion process, we're going to be providing format in order for this data to be adequately handled, and in order for providing an amenable way in which this data can be therefore presented later on. So basically, we're going to have a subscription-based service, and this subscription-based is going to be, in this case, related mainly with the extraction of the measurement of wireless signal levels. We're going to see that these wireless signal levels can be used for different aspects. But initially, what we're going to be aiming towards is the fact of extracting basically the levels of a signal and identifying which is going to be the node which is emitting the signal. So once that we have already obtained the data feed, and by doing this, we're going to be using the Kafka, what we're going to do is that we're going to be converting this data feed into an amenable format that can be ingested directly within a conventional data storage system. And for that, we're going to be using NIFI in order to provide this JSON format in which it can be easily converted within the database. Here we have an example of the data conversion algorithm that is going to be employed in this case. Now, once that we have already performed the conversion towards JSON for the database based on NIFI, then we are going to be sending the data towards our data storage system, which is going to be the database that has been implemented within the city of Pamplona within the framework of the Stardust project. In order to do this, we're going to be using normalized data storage, which is going to be based on the use of MySQL. Now, basically, what is it that we're going to have within the opportunistic sensor nodes? Well, these opportunistic sensor nodes are going to be basically distributed spectrum analyzers that are going to be capturing the signal levels that are going to be monitoring the levels within the city. Now, basically, what we're going to do is that we're going to take advantage of the fact that any smartphone today, or the vast majority basically, are going to be Wi-Fi enabled. So in order to provide an amenable extraction of data, we're initially going to implement the system in order for it to be capable of collecting the information related with Wi-Fi signals. So basically what we're going to do is that each one of the mobile devices is going to be running a background application, which is going to be collecting the RSSI data. It's not only going to be collecting the RSSI data, it's also going to be correlating this RSSI, which is going to be the received signal strength indicator, the level of power and dBMs and that we're going to be detecting, correlated with what is this the identifier of the Wi-Fi access point that is providing this this service, which is going to be the service set identifier. So basically, once we collect this, we have binary data sets that are going to be couples of RSSI, SSID. Then we're going to build a JSON that is going to contain this information. And this JSON is the one that is going to be sent to the cloud. Here we can see an example of the sensor node code that is employed to extract the data and the JSON format that is implemented in order for it to be ingested by the database. So basically what we're going to do is if we go back to the initial statement of what is the architecture of this data ingestion and visualization system, we're going to be capturing the data from our terminals. There's going to be the data conversion to JSON in order for it to be amenable for the MySQL database. We are going to convert this JSON format to something that can be directly ingested to the MySQL based on the NiFi stream. And from there, we're going to be using data visualization tools in order to provide some type of signal mapping. And here we have two examples that have been obtained within this system, within the city of Pamplona. On the left-hand side, you can see basically an identification of the number of access points, Wi-Fi access points that have been detected by using the opportunistic sensor nodes, which are going to be mobile telephones that have the background application installed by the users in order to perform tests. Whereas on the right-hand side, you can see an example of mapping levels provided for the average RSSI levels that have been detected within the time period under analysis. So basically, here we can see also the implemented app that has been done in order for users to have access to the information and to configure it. Of course, it is in Spanish because it has been deployed within the city of Pamplona. It would be no issue to translate it. And basically here we can see some of the examples related with the data processing and data recording information that we can obtain, and the different types of menus of this implemented application, which is quite amenable and easy to use. From here, we can basically extract the data, we can touch configuration parameters, extraction parameters, and visualization parameters. Now, in order to conclude my presentation, basically we have presented a distributed wireless Mapplicationing system, which is going to be taking full advantage of the opportunistic sensing capabilities provided by different smartphones. In order to do this, we're going to be employing an ad hoc implemented application running in background, which is going to be using the geolocated information of Wi-Fi hotspots and the combined SSID, RSSI data. In order to extract the data and visualize it, we're going to have a cloud-based architecture. And from this information, what we're going to do is that we're going to be capable of implementing reports that are going to be providing us info such as human exposure distribution, connectivity optimization, crowd sensing, energy harvesting for rectennas, etc., etc. As future work, we are going to have full system integration and field trials to be deployed in order to have massive testing of the application. So with this, I come to an end to the presentation. I thank you very much for your time, and I'll be very glad to answer any question you may have. Thank you very much.